You spin around a few times as a kid, or maybe you just stepped off a fairground ride, and suddenly the world won't stop moving. You're completely still, but everything around you is spinning. Your legs feel unreliable. Your brain is lying to you. So what exactly is happening inside your body? The answer lives in one of the most sophisticated and underappreciated systems in the human body, your inner ear. And what it does during and after spinning is a perfect example of your brain being confidently wrong. Deep inside each of your ears, beyond the parts involved in hearing, sits a structure called the vestibular system. It has 3 tiny, fluid-filled loops called semicircular canals, positioned at different angles to detect movement in 3 dimensions: up and down, left and right, forward and backward. Together, they give your brain a constant, real-time map of exactly how your head is moving through space. Here's how it works. Inside each canal, there is fluid called endolymph. When you move your head, the endolymph sloshes around, bending thousands of microscopic hair cells lining the canal walls. Those hair cells send signals to your brain, telling it exactly which direction and how fast you are moving. It is an extraordinarily precise system that works seamlessly every second of every day without you ever thinking about it. Now here's what happens when you spin. When you spin around, the fluid in your inner ear moves, signaling your brain that you're spinning. So far, so good. Your brain is getting accurate information. But here is where the problem begins. When you stop, the fluid continues moving briefly, making your brain think you're still spinning, which causes dizziness. Your body has stopped. Your eyes can see that the world is stationary, but that endolymph is still sloshing around, still bending those hair cells, still sending the signal. You are spinning. Your brain is receiving 2 completely contradictory messages simultaneously. Your eyes say stopped. Your ears say still moving. That conflict between sensory signals is exactly what dizziness feels like. If you spin for long enough, the brain gets desensitized to the constant turn signals from your ear and adjusts to zero them out. When you stop, the ears correctly report 0 turning, but your brain is still actively canceling this out, and so it thinks you are now spinning in the opposite direction. Which is why experienced ballet dancers and figure skaters who spin constantly train themselves to suppress this response, a technique called spotting, where they fix their eyes on one point to give their brain an anchor point of stable visual information. The dizziness fades as the endolymph slows down and the conflicting signals resolve. Usually within 30 seconds to a minute, your inner ear fluid settles, your hair cells stop firing incorrectly, and your brain reconciles the contradiction. The world stops spinning. And here's a fascinating extra detail. You can actually reduce the dizziness by spinning in the opposite direction immediately after stopping. Spinning in one direction and then the opposite can help cancel out the dizzy feeling because it moves the endolymph in opposite directions, reducing the sensation of dizziness. Your vestibular system is one of the oldest sensory systems in evolutionary history. Fish have versions of it too. It is essential for balance, coordination, and your sense of where you are in space. You rely on it every moment you are upright. And the only time you ever notice it is when it briefly, gloriously gets it wrong. If your body is doing something strange and nobody has ever properly explained it, that's exactly what this channel is for. Subscribe, because next week we're covering why you hiccup and why they are so hard to stop.